All right, we'll get started tonight. So first, I just wanted to say welcome. I'm Beth Martin, and I'm director of the Climate Change Program here at Washington University and a teaching professor in environmental studies. And we appreciate you all joining us. This is our first year, our inaugural year with our Climate Change Program speaker series. And we're excited to have with us tonight Dr. Scott Tinker. So first, I wanted to go over a couple of Zoom functions. Just a reminder, we're using a spotlight function tonight. So each of our speakers will be spotlighted. So you'll be able to see them primarily when they're talking, and then during the QA, Professor Bradley and Professor Tinker will both be able to be seen on your screen. You also, though, will be able to kind of still see in Zoom mode all of the other participants. So if you kindly would make sure your sound is muted, and then also have your camera turned off during the presentations, that just can help a little bit with distractions. So again, if you choose the speaker view on the top right corner of your screen, that's how you'll see who we have spotlighted. So to get us going and to get into why you're here, I first would like to introduce Alex Bradley. Alex is going to be moderating and doing our Q&A tonight. Alex is an associate professor in Earth and Planetary Sciences, as well as the director of graduate studies in the department. And so Alex, thank you very much for being here and being willing to shepherd us through. And I'm going to turn it over to you.
Thanks, Beth. Welcome, everybody. Good evening. I'm really happy to introduce today's speaker, Scott Tinker. So Dr. Tinker is a geologist and a professor at the Jackson School of Geosciences at the University of Texas at Austin. His area of expertise is energy, and he's had a very diverse career that has involved stints in the oil industry, at the Texas Bureau of Economic Geology, at the University of Texas. He is also the State Geologist of Texas, and also the host of Earth Date, which is a show about earth science that airs on National Public Radio. Perhaps most relevant to tonight, Dr. Tinker is the founder of the Switch Energy Alliance, which is a nonprofit dedicated to objective, nonpartisan energy education. And with that alliance, Scott has been featured in 2 films. The 2012 film Switch focused on the global energy transition from coal and oil to future energy technologies. And watching that film was really what inspired us to invite Scott to meet with us tonight. His new film, the 2020 film called Switch On, focuses on energy poverty in the developing world. And so we are really happy to have him with us tonight. And so I'd just like to say, Scott, welcome. Happy to have you.
Thanks, Alex. Great to be here. I will share my screen and hopefully, is that good? Can everybody see that? All good? Can you hear me?
Oh, yep, all okay. Good. We can hear you and it looks great.
Great, thanks. So it's really nice to be here, and thanks for the nice intro and for the invitation to speak with you tonight. I'll start with my favorite philosopher, Yogi Berra. If the world was perfect, it wouldn't be. And for those of you who know Yogi, he had a lot of these. So perfect for tonight, you know, does everyone have sound? This is my favorite image, I think, for Zoom, and I was just doing it myself. Can you hear me? So let's start with some big picture things here. These are a lot of issues in the world that I think most of us would agree are major. And I'm going to highlight, color many of them because I don't have the word poverty on here, because many of these things relate to poverty today. Energy sits here, as does climate change, and some would try to paint kind of climate or energy as polarized. I think if we think about the other components of the environment as well, the land and the air and the water together, atmosphere, land, air, and water, it's really conjunctive. Climate change and energy and land and air and water, we're really talking about the environment and energy and poverty in many ways here. Okay, so poverty is part of the larger economy. So this is the waltz, the 3E waltz, and I've spoken about this for many decades, for better or worse. Energy, the environment, the economy. The pillars of the environment, economic things, poverty, competition, growth, and different kinds of energy. And it's complex. You know, there are legal, social, political systems. It's not simple. They're very interactive. You see that in our own political system. I call that overlap space the radical middle. We'll talk about that a little bit near the end. But it's kind of radically lonely at times. It takes critical thinking, and that means looking at multiple sides of an issue, the pros and cons, as objective as we can be. We all have biases, I particularly do, and we all do. But this whole concept that the right owns fossil and nuclear and the economy and the left is renewable and the environment, it's not particularly critical thinking. It kind of reminds me of this picture. Oh yeah. The boat part goes in first. We have to actually think about things critically. So I'm gonna challenge you here at the start. Renewables are clean and good, and fossil fuels are dirty and bad. Candidly, that's not particularly critical thinking. What is? Energy makes the modern world possible. There's so much that goes on, and all forms of energy have significant environmental impacts. They're just different. We'll talk about those. So a question, critically thinking, how can we best minimize the impacts of energy? Another example, there are climate believers and deniers, all right? Well, there are varying levels of understanding, to be sure, of the multivariate, nonlinear, complex climate system. And some are pretty low levels. But we got to be cautious. There are different levels and approaches to global investment in climate mitigation and adaptation, too. And so this isn't simple by any means. Do judgmental labels help? Is that critical thinking? Here's one. Renewable energy is the only path to address climate change. You might think that yourself. Addressing climate change requires affordable, large-scale, global emissions reductions in a relatively near-term time frame. Okay, so what are the big things? And we'll talk about some of these. What approaches will work to address climate change? And one last one. Renewable is sustainable. Well, is it? In fact, it turns out no energy collection system is renewable. We'll talk about that too. The sun and the wind are, but the stuff to collect them aren't. All of them require extensive extraction of materials and disposal of Earth resources. Sustainability has to consider a time frame. It has to engage energy, the economy, and the environment together. Or maybe it won't even work if we don't pull all those in. Are there nonpartisan sustainable solutions? That, I hope, tees up some thinking. And here's another philosopher, not as famous as Yogi Berra, to be sure, but it's the mark of an educated mind to be able to entertain a thought without accepting it. And wouldn't it be wonderful if we could have civil dialogue and conversations that entertain a lot of thoughts? Not easy, but civilly, and you don't have to accept them. So let's try to do that some tonight. And I'm here to help us all try to think hard, if you will, about a lot of these challenges. So global sustainability, it engages the economy and energy and the environment. We're going to start with the economy. Energy poverty. What's it look like? Well, people. Who live in poverty? People. The red is where we're densely populated, and the white, not many people live in the world. And you can think about where these regions are and probably guess why not many people are living here. Now, you think about urban populations, close to 80% of people live in cities in high-income countries. It's true in the United States. Low income, on the other hand, around 30%. And India represents this. And by the way, it's not high or low. It's a transition and a gradation globally here. But you see, China is migrating to cities. Indonesia has begun to develop economies and emerge from poverty. Migration to cities is very common. In fact, 150 million people, plus or minus, are moving to cities every year. 150 million. And they don't always live well when they get there. Now, coming back to a different map of the world, we'll highlight our areas where not many people are living again. And then look at income. $3 a day in the yellow, $10 a day, about $4,000 a year in the reds. To be sure, all around the world we have that level of severe poverty, but it's concentrated in some areas that I've drawn ovals around. And we made a film called Switch On. I'm not going to dwell on this at all, but I'm just going to put some teasers out here, if you will. We went to Gunchukwu and brought first solar to an indigenous village, distributed renewable energy. We came over to Africa, into Ethiopia. Mud huts and thatch roofs, very similar, but a very different solution. One of the largest dams on the planet being built there, the Grand Ethiopian Renaissance Dam. We went to Nepal and looked at clean cooking. The great challenges of cooking indoors with biomass and wood and dung and other things. Came back to Africa, to Kenya, and looked at under-the-grid poverty. electricity, but in severely large slums and mostly can't afford it. And there's corruption and cartels that run these. And finally over to Vietnam, where they've emerged and they're developing and competing with other Southeast Asia folks. We talked about how they're building their economy on coal today. And so these are some of the things that I'm trying to encourage you to watch the film, and it opens us up to thinking about these. Now, as I lift that income toward the higher end, $12,000 a year, or more, severely more in some places, but $1,000 a month, that's the blue. There are not that many blues in the world, are there? Put some geography on here, and you can see that north of 20 and south of 20, the tropics, it's interesting how these are divided. So I come to an annual mean temperature of the world today, and we don't live where it's really hot or really cold. In fact, the wealth is where it's just right. You know, not too hot and not too cold, Goldilocks, if you will. And it's north and outside the equatorial regions for the most part. And it's poor where it's really warm. And so in that 20 to 30 degrees C range, if you increase temperature of the world 3 degrees C, that's almost 10% plus or minus. There's a warranted concern that warming will hurt the world's poor, particularly in these regions. What helps? Different map of the world. This is energy at night, composite satellite photo of lights at night. Where is it wealthy? Lights are on, okay? They're on a lot, and not just lights, it's a lot of other things we use electricity for. In fact, a plot of every country in the world of lights at night against GDP per person, pretty strong correlation here. And this isn't causation, but there's a correlation between access to electricity and wealth. And where is it poor? Not many lights, are there? Some in the coasts, etc., but a big challenge of energy access in these regions. So there's a warranted understanding that energy will help the world's poor, just like it has helped and continues to help the world's rich. So what does it really mean? What does little to no energy really mean? There's three kinds of people in the world. Those who are good at math and those who aren't. So which of the three are you? Here's some simple arithmetic. The average Ethiopian consumes 52 kilowatt hours of energy per year, electricity. If you don't speak kilowatt, I'm going to compare that to my fridge. My fridge consumes 9 times more electricity than a human being in Ethiopia. 9 times more, and 3 times more than a Kenyan that we featured in Switch On. That's energy poverty. So if I compare energy poverty to economic poverty, we see severe poverty across the bottom against electrification rate of different countries in Latin America. Brazil is the largest population. Countries are mostly electrified, 90%, with some severe poverty. Same scale Asia, a lot more people, less electrified, more poverty. Another 1 billion people in Africa, less electrified. You can see Kenya and Ethiopia again, and severe poverty. So again, not correlation causation, but this relationship between poverty and access to electricity and energy is very real. It creates a paradox. Energy doesn't end poverty, but you can't end poverty without energy. Now, how many people live without electricity in the world today? About 1 billion. The trends are good, coming down from over 1.5 billion just 20 years ago. But 1 billion people. Here's a population map of the world, color-coded. Every color is about 1 billion. We're not evenly distributed. Take a look. The Western Hemisphere is about 1 billion people without electricity today, equivalent in the world. How many cook like Sana Kanchi, who's featured in Switch On? Wood, dung, biomass, indoors, and all the health hazards that go along with that. Turns out about 1/3 of the world is still cooking that way. Over 2.5 billion people in the world today. Smoke kills 3 million people a year. Indoor smoke from cancer and other diseases, pneumonia and lung diseases, cataracts. 3 million. About 1.3 or 4, I haven't checked in the last couple of weeks, have died globally from COVID-19 in the world today, and that's a terrible thing. 3 million will die this year from just breathing smoke every single year. And this is so solvable today. So the last way to look at this is GDP per person on the bottom against electricity consumption per person. And about 30 years ago, I've shown some large economies. There's a pretty strong correlation between access to electricity and wealth. Now, fast forward 25 years and you see the wealthy nations double their GDP per person without going up too much in electricity consumption per person. The middle countries do both, up in energy and up in wealth. South Korea particularly. Look in the lower left corner. There's China and India. in 1990 pinned no electricity to speak of and no wealth. Severely wealthy people in those countries, to be sure, but in the aggregate. Watch China move and India barely move across a quarter of a century. So now we see this different kind of trend. It's not really a straight line. It's starting to roll over. In fact, highlighting just 4 countries in the world, about a third of the world's population live in these 4 countries. You see you need electricity for a while, and then it can start to flatten, and maybe even roll over. China's economy, by the way, the global GDP, is much larger than the United States today. Not per person, but in the aggregate, much larger, and on an upward trend. So looking at all the countries again, we made the film that Alex mentioned called Switch, and electricity was the star, energy was the star. Lots of countries, etc. But I got back with the filmmaker Harry Lynch, who's the brains behind all this. I'm just the pretty face, you know. And I said, hey Harry, you know, we left off about half the world. We need to make another film and look at those who don't have much energy. Because what do they want? They're going to grow and industrialize. And it'd be wonderful if they could do it without consuming as much energy per person. There's better technologies now. So you have 1990, you have 2015, and perhaps we can even increase and lower that energy curve per person to gain the same kind of wealth. And that gives me some hope. But it's time to power the people. And 2 of the greatest inhibitors to energy access are distribution, getting the energy there, and corruption. And we'll talk a little bit about both in the Q&A if we have some time. So let's go to energy now. Again, our population map of the world. My slides are all color-coded. Green is oil, red is gas, gray is coal, nuclear in orange, hydro in blue, and renewables in shades of yellows and light oranges. Okay, so that's the color scheme. About 85% of the world's energy today is oil, natural gas, and coal. Now, it varies geopolitically. North America is about like the world's mix, and so is Europe. Russia is half natural gas. And this isn't power fuels, this is total energy. South America has more topography and rainfall, more blue, hydro. Africa, more gray, more coal. The Middle East is largely oil and gas. There's a new nuclear reactor and solar going in. Now look at Southeast Asia. Count colors, 1, 2, 3, 4 billion people get half of their energy from coal. I'm going to shrink and grow these to be proportional to actual consumption or demand. That's how much is consumed in these different regions. Half the world's population is getting half of their total energy from coal today. That's more than the rest of the world's coal combined, times 3. That's the data. Has it changed through time? It has. You see from 65 to now, growth almost of 400% in energy consumption. Oil and coal, not as much as total growth. Natural gas more, and then nuclear and hydro and renewables are starting to come in. So the mix is quite different. In fact, what else is growing? We are. The population of the world, this is a mid-range UN forecast, headed to about 11 billion by the end of the century. Who consumes energy? We do. This is causation. Humans consume the energy. Now, if I color code this by population, about 4 out of 5 people live today in Africa and Asia, and they consume less than half of the world's energy. The rest of the 20% that's remaining consumes more than half. Now the trend's changing. Look at the red line. Asia is increasing its energy consumption tremendously, and Africa is just getting started. We'll look at the data. So population-wise, oops, I'm sorry, I hit the wrong button. Get back to my talk here. I only do that about once a day, so. Oops. Here we go. Sorry about that. Population-wise, did I stop sharing my screen? Are we still sharing?
You did. Can you reshare your screen?
Oh, sorry about that.
That's all right.
We'll get this figured out here. Looks like I'm completely, oh, there it is. All right. Are we back? My screen back?
We are back.
Okay, sorry about that.
No worries.
Fat fingers in the right place. So population, Western Europe and the United States, we're about 520 million people today, combined population. The global population is between 7.7 and 7.8 billion. We're less than 7%. We're actually decreasing percentage-wise. Western Europe and the United States combined. Energy demand is growing globally. So we need to be thoughtful. The world is excited. I've been fortunate to be in 65 countries in the world on all 6 inhabited continents. There's a lot going on as the world begins to emerge and develop its economy. Okay? Now you'll hear the world could be wind, water, and solar if it's just for political will. You can hear that recently. Or what would that look like? If I drew a picture for you. I modeled this out to 2065 by when? And that's dominantly solar and wind and hydro. Okay? Some are saying by 2040 now. And I just have to ask you, how does that look to you? Does it look possible? Okay? What if it was 75% renewable? How about 50%? Maybe only 25%. And only means all of the new demand in the world is satisfied by renewable energy, plus a little bit. Is that business as usual? There's the same exact data with a 25% renewable by 2065. And you can see the demand growth I've modeled a little lower and what it looks like on the far right end. Now the exact same data, instead of in units here, in percentage, the energy mix. Left to right, we see oil and coal are cut in half, natural gas and nuclear double, and the renewables go up fourfold, 400% in that time frame. The right side of that mix is nothing like the left side. This is called, by most, a business as usual case. But it depends on how you look at the data, doesn't it? How you think about all sides of that discussion. Now that's a lot of oil and gas in the future, if that particular future is real. And does it exist? Well, here's the United States crude oil production. It was plummeting as kind of forecast. The imports were going way up. There was a lot of security issues around that, and we were exporting nothing. And then something happened. Things changed a lot. Shale happened. Hydraulic fracking happened. Okay? Oil production went way up in the United States. It doubled. Imports were cut more than in half, and we began exporting some oil as well. In fact, if you look at the big shale gas basins, a lot of data here. I have a big team that's been working on this for a decade. The only thing I want you to focus on tonight is the size of the circles. The big red circle in the Barnett, that's how much gas is in place. A lot of work going to figure that out. The little circle is all that's been produced with all the drilling so far. In place, what's come out? Same scale to Fayetteville and the Haynesville, and there's the Marcellus. And that was a subject of much discussion in our recent presidential contest. So look what's come out of the Marcellus. On the oil side, a lot of oil, a little bit out of the Bakken, Eagle Ford, and here's West Texas. A lot of oil. In fact, just in two horizons, the Wolfcamp, big oil, a little bit of production. About 3% of the gas has been produced and 2% of the oil. And the world has shales. The Middle East and Saudi Arabia and others have a lot of source rocks that they're producing as well. So there's the resource here. And let's just have a few COVID thoughts then. Sit, Oh, it sits. Damn mask. And I can relate to this because my wife and I just got our second little hunting dog. And I've been doing this a little bit with little Cleo recently too. But let's have some COVID thoughts. And 2020 kind of reminds me of this. It's not Cleo, but boy, when will it be over? And we probably all are starting to feel like that a little bit. So what's happened? On this demand side, well, cars on interstate highways in the United States, the traffic plummeted by 50%, but it's all the way back now. It's 10 or 9%. In fact, truck traffic is higher than it was pre-COVID. Guess who's bringing you all that Amazon stuff? Okay, so the demand has already come back. If you look at the rig count for oil, it went way down. Like there's the counts in hundreds, and it plummeted to less than 200 because of COVID, and so did oil production. It plummeted from 13 million to 10 million barrels a day. That's a lot, 3 million barrels a day less. Okay, now globally, we see world consumption plummeted with COVID. We shut down the economy of the world. We said stay home. Okay, for good reasons, many good reasons, but that's what happens is energy consumption goes way down. Guess what? Production followed that. Consumption leads production. If you don't need it, we're not going to produce it, say the different industries that do that. So production lagged but followed. What's coming, however, is consumption is starting to go back up, but production can't keep up. So production is lagging consumption now. When that happens, when demand is greater than supply, you see changes in price. So here's the price of oil with the world standard, the Brent crude price. And you'll hear the oil and gas industry is dead. It's not coming back. You hear that from a lot of people. That's actually, in my opinion, far from the truth. The world is demanding a bunch of oil and natural gas and a bunch of energy as it develops. But the investment in oil and gas, look at, you think they're tied here? Price goes up, more investment. This is in trillions of dollars. Price comes down, less investment. With this low price in COVID, the investment has come way down. Supply is lagging demand. It's just starting. Price is going to go back up, and we go into one of these big global cycles again. So there's a lot of COVID impacts on the oil and gas side of things for sure, and all energy, in fact. Let's talk about electricity, though, which is really the climate change or renewable energy conversation. I'm going to challenge our thinking here a little bit, critical thinking. A lot of people don't know how we make electricity. We think we do, but I've heard many people say, oh, it comes out of that plug there in your wall. And it does, but that's not, we don't mine it, we don't grow it, we make it. So we burn coal, boil water, make steam, turn a turbine, and run a generator. We burn oil, and we burn ever more natural gas. So this is called thermal generation. Nuclear is the exact same process. The heat's just a different source, radioactive elements. Gravity from hydro, natural gravity by flowing it downhill. Solar is both thermal and direct conversion. Wind is natural motion. And then geothermal and biomass, some heat and burning different kinds of carbon, biomass. That's it. These are the fuels to make electricity. And you can see the global demand is growing steeply. In fact, the slope is higher than it was 20 years ago. Now, focusing in on where it's consumed, the OECD nations, that's the club of rich nations that we happen to be in, have been flat in our consumption of electricity for about 15 years. The developing nations, look at that slope. Way up, long since past the OECD and won't come back. A little more granular look at that would show North America and Europe flat in consumption for about 15 years, and look at Asia. Just in 1985, essentially none, and look where it is today. The rest of the world not consuming much electricity yet. Remember the map of wealth. Takes energy to build economies. There's not much energy consumption in large parts of the world still today. What countries use the most? Well, the biggest economy is China, and they use the most electricity. The U.S. is next, and this is 2012, and I just showed you 2018 data. Look what happened in China. Way high. India almost doubled. Now, somebody's missing here. Who's number 3? Turns out it's the tech sector. The tech sector consumes more electricity than any nation on Earth, except for China and the United States. Just look around. You might be on your phones right now. Kids are on them. This was a picture I took at our youngest back in high school on a soccer game. We were dutiful parents all watching closely, on our telephones. So this thing called the cloud and the tech sector, technology consumes 4% of the world's electricity today, and growing steeply. The cloud alone, it's not a cloud, as you know, it's giant data centers, and they produce anywhere from 40 to 400 million tons of CO2 emissions every year to do what we are doing right now, to stream videos and to stream online. No wonder it's called the cloud. Maybe a different name they would choose the next time. And it's no wonder Jeff and the gang are making promises or pledges. Net zero by 2040, 100% renewable by 2030. Countries, states, companies, the pledge frenzy is on. What sits beneath these? What's underneath those pledges? How's that going to happen? We'll talk about it. Come back to coal production then. Here's coal in the United States. We built our economy on coal, and it's coming down pretty steeply. Look at China, same scale. 120 gigawatts of coal under construction in China today. That's 120 big coal power plants or more. 23 gigs of wind. You'll hear China is the renewable energy of the capital of the world. It is. 23 gigs is about what we have in Texas, and Texas has more wind than any other state by a lot. China's building that in 2018. But 6 times more coal than that. And here's India. Now, India and China share population about the same, but look at India compared to China. In fact, India looks like China about 35 years ago. Let's just shift India to the left and say, where is it headed? Maybe it's going to follow the red curve, unless they have options. So here's the coal consumption in the world, and it shouldn't surprise you, that red is Asia. North America and Europe have come down, and the rest of the world doesn't consume much. Asia, coal. This is natural gas for power generation. It was 38% natural gas to coal ratio back in '85. It's over 60% today. So we're changing coal for gas, and that's a good thing. SOx and NOx and mercury and particulates, less CO2, but still CO2, methane for sure for climate. But other climate impacting things, much less natural gas than with coal. Solar is growing more steeply than anything. You'll hear solar is growing faster. It's true. In rate, look at the exponential growth of solar. And here's all of our electricity again. I'm going to lay wind on top of that. And wind is growing exponentially as well. Much faster rate than the growing electricity demand in the world. So you'll learn, probably have learned, your kids learn if you're faculty, that solar and wind are growing faster. It's a true statement in rate. But let's look at something else. How about an absolute production? So now I'm going to scale the wind to be the same scale as the global energy demand. Here we go. Remember, it's in the data. It's the light orange color here. That's wind. In 15 years, and we built the best wind first. We've gone to the best wind resources first. Wind and solar don't even account for the growth in electricity demand globally. They're not growing fast enough to keep up with the growth, much less meet the base load. And this is one of the great challenges of scale, and we have to understand this in order to be able to do things about it. So here are the data. Renewables, non-hydro, so all wind and solar plus others, grew up 14% 2017 to 18. 300 terawatt hours actually generated. Natural gas only 4, coal 3, but over 500 hours actually generated from those. So rate is much higher, actual generation is higher here, and that's what sits in all the data. Okay? Let's talk about the environmental impacts of that reality then. The atmosphere, climate, this is a climate symposium. It's important, but so are the land, the water, and the air. Okay? So where does the CO2 come from? Lots of different sectors, and they're scaled. The boxes are about the proportional size. Industry, transportation, burning it to drive ourselves around, heating and cooling things, making power, and then a lot of forestry and ag and land use, almost as much as power gen. We focus on about half of the human sources, the power and the transportation, but the other half still exists. Where? We'll pat ourselves on the back, North America and Europe. Emissions have been flat for 40 years and are coming down. Where are they going up? No surprise, Asia, over 50%. Bad, bad Asia, making all that CO2. Well, what's really going on here? This plot shows CO2 emissions globally across the bottom against a ratio of consumption and production. Above the red line, we consume more than we produce. The United States makes about 5 gigatons of CO2 in the atmosphere every year, and we consume more than we produce. China makes 10 gigatons and growing, but they produce more than they consume. In fact, many of the non-OECD countries, the producers, the blue, produce more than they consume, and many of the rich countries, the green, consume more than we produce. I just spoke in London yesterday and showed Britain on the far right end. So what's going on? Well, the producers are sending stuff, a technical term, to the consumers. Lots of stuff. In fact, Southeast Asia makes about half of the world's major stuff today and growing. And what effectively are we asking them to do? We're asking them to emit the CO2 when they make that stuff. And if we're buying credits and patting ourselves on the back for being green because somebody else is making our stuff, is that a zero emission strategy? This is going on in US states as well, and in companies. Buying credits, making pledges by buying lower emissions from someone else, but there's not enough to go around. How many atmospheres are there in the world, climate scientists? There are one. So this isn't lowering emissions. Okay? It's not a good strategy for lowering atmospheric emissions to have other people make your stuff, especially when the regulatory regimes are less stringent than ours are. on a per product basis, it's actually more CO2 per product. We've got to think deeply and critically about this. The intentions may be good. These guys had good intentions. They're putting in posts to keep people from parking next to the building. They forgot where they parked. Okay, and this happens with policy too. It's well intended, but often the intentions don't bear out. Many examples of this, and we have to be willing to adapt. So what's happened in the United States? Look at coal. This is electricity generation only. Look at coal. Way down. Oil's down too. What's gone up? Natural gas. A lot. So have nuclear's hung in there, and renewables have gone up quite a bit as well. So shale is what drove that increase in natural gas. It made it cheap. I've already showed you the data. Abundant and cheap, and it replaced coal. Now we zoom into the renewables. Just, a lot is called renewable. Almost half of that is actually carbon, wood, biofuels, and biomass waste. Another less than a quarter, hydro and geothermal, and about a third is solar and wind. A third of 11% of the increase is solar and wind. So that's the renewable breakdown in the United States today. That's the actual generation. As a result of that change, though, our emissions have come down 700 million tons a year. 700 million tons in the power sector. Now, what happened in 2005? We were at 2,400 million tons, and in 2015, we were at 1,900. 2015 was the Paris Accord. The U.S. proposal for power sector was the Clean Power Plan. We didn't implement it. But the proposal was to reduce emissions from 2005, when they were the highest, 32% by 2016. That's 1,600. 2,400 to 1,600 by 2030. Okay, that was the proposal. Guess what? We're already there. We're there a decade early. In 2020, without COVID, we'd be at about 1,600 million metric tons of CO2 from our power sector. It's remarkable. We didn't sign it. We're going to rejoin it. But we did it. How did we do it? Fracking. Gas replaced coal. That's a big wedge. Renewable policy, mostly in the States. That's a big wedge. Efficiency helped. And then that whole exporting thing, getting our stuff made somewhere else. That doesn't help the climate. It just helps us look good. By the way, a lot of nations are doing that same thing. But we did a lot of very real things to reduce emissions. Did you know that? Did you know we were already there in the power sector? You wouldn't know that probably from what we hear or read. But those are the data. What if the world could do this? What if Asia, who was making 3 times as much coal to gas in '85, and now 5 times as much coal to gas, and since they've both gone up, it's 10 times the amount of coal being used in Asia today than was in 1985. In the United States, it's flipped. We were 5 times coal to gas in '85. Thanks to hydraulic fracturing and shale, we're now 0.9x coal to gas, more gas than coal, and 8 times the amount of gas. Still challenges with gas, but that's a lower CO2 scheme, as you've just seen. If Asia would do that, or could do that, switch from coal to gas even, that's a big wedge. And if you start to capture and store that CO2, that's an even bigger wedge. That is an important component of scalable today that we could reduce. Nonetheless, there are still folks who don't like natural gas. You might be one of them, I don't know. Because it's a fossil fuel. It's mostly hydrogen, CH4, methane, CH4. Mostly hydrogen, very different from coal. But here's one of these things. I took this picture in Aspen. You sit outside and you sit under this warm thing and have your meal and you heat the atmosphere directly. You just remove the middleman, I guess. But, people in Aspen are very climate aware. You know it because on the propane tank it says no global warming. So there's a lot of irony in the world as we go about our business. Reducing CO2. Natural gas with carbon capture and storage. Nuclear, no CO2. Coal with carbon capture, replacing coal with natural gas. Geothermal, where it's available. Hydro, where we can build more dams. Each of these have environmental impacts, by the way. Quite sizable. You'll see that in the switch on. Centralized wind. The big wind corridor. Texas has a bunch of wind now, and other states do as well, in the Midwest particularly. Distributed renewables for the billion people who don't have electricity. There's no roads and power lines and pipelines. Distributed renewables starts that, okay? And then efficiency and conservation. Doing more with less. Guess what? Those top 3 aren't particularly popular in some states, those particularly who are most passionate about reducing CO2 emissions, gas and nuclear and coal wouldn't be the first thing that came to mind, but in fact, those are the largest scale and probably the things that can be done at scale soonest. So there's some ironies here, and it challenges all of us to think hard. We had this little efficiency contest in Austin. You know, I want to be the Ditto house. They won, hands down, for energy efficiency at holiday time. Now, we did pretty well in the power sector, but not other places, not in industry and buildings, and certainly not in transportation in the United States. Those have mostly been flat. So enter the electric car. This is a Beamer electric vehicle. The license plate says electrons. It's charging at an electricity station being run by what? Diesel. Those are diesel generators making electricity. Now, you can't make this stuff up. Sometimes we lose the thread. So let's look at a larger scale globally, what's going on here. This is the electric vehicles in the world today. We're over 7 million now. And there's the growth. That's the total global stock. The light blue and dark blue are China. Almost half of the world's EVs are in China. Now, pure EVs, not hybrids, are around 5 million today. And that's that purple line. Ask yourself a question. Are the EVs being charged in China clean? If clean means lower emission. Well, here's the growth. 800,000, 1.1 million, 1.9 million new 2017-18, and then 2 million 18 to 19. We don't know 20 yet. So the growth rates, the rate slowed tremendously, about the same year on year the last 2 years. And that's typical in things. 2 million a year, maybe we'll get to 3 million a year or more. But are China's EVs clean? Where does China get its electricity? 2/3 comes from coal. That's kind of like charging diesel, okay? And so this is one of the complicated stories of electric vehicles, and there are more. I didn't have any accurate numbers, so I just made this one up. Studies have shown accurate numbers aren't any more useful ones to make up. How many studies showed that? 87. So let's look at a forecast of electric vehicles. This is going from 2020 to 40, only 60 million per year. Here's where we are today. Now I'm going to scale these the same. Get ready. That's the actual today. So we're going to grow from today like that in 20 years. That's a lot. The area under that curve is about 600 million EVs. That would be half of today's vehicle fleet. Half electrified. You say that's reasonable. Half electrified in 20 years. Sounds good. How many batteries is that? Let's do some arithmetic again. And if you haven't seen one, this is what a battery looks like in a Tesla S. This is a lithium-ion battery. It's about 3 inches long, 1 inch in diameter, a cylinder. Turns out there's not one. There's 7,100. 7,000 in one car. That ad you see with all the batteries falling out, it's not, it's real. All through the floorboard and up the sides to run a motor that will move you around like that. So let's do some arithmetic. 600 million vehicles times 5,000 per car, not 7,000, is 3 trillion. 3 trillion new batteries in the next 20 years. What's 3 trillion look like? A U.S. football field. I'm going to cover it in Tesla S batteries. End to end and side to side, no space, is 2.7 million of those cylindrical batteries. I'm going to start stacking them an inch at a time. I got to go with the Longhorn football field since we don't get to go to the games. Here we go. An inch at a time. How many inches to get to 3 trillion? Well, we leave the stadium. In fact, we go higher than Mount Everest and cumulonimbus clouds, above spy planes and blue jets into the stratosphere. That's a solid stack of lithium-ion batteries to power half the world's vehicle fleet. Okay? That's half, and guess what? We got to make them again in 10 to 15 years. So we need to begin to ask ourselves critical questions when the proud Tesla owner in Colorado says no oil on the license, and that's fine. I love Teslas, by the way. The motor's amazing. The battery isn't such a good fuel, but the motor's amazing. I guess they don't have any tires or plastic in this because those take oil, but we're talking about mining. What we're talking about with batteries is mining. Who controls the rare earth exports in the world? China does, by a lot. Lithium and cobalt are going way up with mining. And again, as a geologist, I don't mind mining. If you don't grow it or mine it. But they're going way up just for our gadgets, not for cars yet. Who controls lithium and cobalt? 60% China, lithium, 70% cobalt, China. Only about 15% of the nickel so far. And if we're going to charge those batteries with Solar panels, who controls the production of the mining for producing solar panels? China. 60% of the polysilicon, and it was zero in 2005. Now these are just the data, and it's not just a security issue, it's a human rights issue. You can't pick up the paper today, this is just a week or two ago, without reading about human rights violations around mining, okay? Conflict minerals. So data must be used to tell the truth, not to call to action, no matter how noble the intentions. And faculty like me and you have to be very cautious about this. Hans Rosling's beautiful book called Factfulness is worth reading. And this quote was buried near the end. I just pulled it out of a paragraph, and I thought it was really worth thinking about. Not to call to action. So what are the data? The environmental impacts of coal and oil and natural gas are very real, and they always have been. The mining and the manufacturing to extract, the drilling and the completion, the land and the water use, the handling of the water, recycling some, disposing, earthquakes, moving in pipes and trucks and ships and on rails, hard, sometimes damaging. Refining and petrochemicals are big chemical plants. Combustion, the CO2 emissions, the leaking of the methane. It's getting better in developed economies. It's not getting better in developing economies. Can't afford it yet. But it worries people, right? It worries you, students. This is taken, I know when students were not in school, and you were exercising your right, which I admire, to protest globally and save the earth. And I like that. But what were you asking or protesting for the most part? You were protesting for renewable energy, solar and wind. So let's take a look. Oh, wait, you got to mine and process for all the elements that go into solar panels and wind turbines and batteries. Got to manufacture those. Take a look at a battery manufacturing plant. It's called the Gigafactory. It's got a cool name because Elon did it. It's a giant chemical manufacturing plant. And we're going to be making 3 trillion of those if we electrify half the world's vehicles. The land use itself is pretty well talked about. Moving the electricity, just like other kinds of energy, is difficult. We have 5 major 345 kV power lines in Texas to move all that wind to the cities. And finally, where does it go? You're cutting up the turbines and burying them in Wyoming today. Solar panels have some toxic elements. We don't recycle and reuse them very much. We bury them in landfills, and batteries are the worst of all, up to 100 toxins in chemical batteries. So I'm going to ask you a tough question. Is mining green? Is chemical manufacturing green? Is landfill disposal green? Why are EVs green? They're just different. Not the emissions at the tailpipe, the way you charge it, but a different kind of environmental impact, for sure. So these are some kids in Kibra, outside of Nairobi. I took this picture inside their school. They had just gotten 2 light bulbs for the first time ever. And they were studying the past and present tense in English. This is a book. These are books. This is a cup. These are cups. And these young kids want to be in school. Their parents are dying for them to be in school so they can start to get educated and change their status in the world. Okay? Energy underpins the economy. I showed you a lot of data on that. Healthy economies can afford to invest in the environment. Slum after slum in the world, I've been in 65 countries, almost without exception, the worst environments are where it's poor. These are young girls coming home from school. Piles of garbage, polluted water, polluted soils, local air is terrible. Over and over and over again, can't afford the cleanup or the regulation. Clean air, green and yellow is the cleanest by far. It's where it's rich, okay? Where's the high particulate? Where it's poor. Over and over this relationship, energy, the economy, invest in the environment. So back to our satellite at night, there's the energy, and that's the amount that's consumed. Now you can see where the lights are on and why. There's energy. And if we remove 85% of that energy, some plans out there to try to do that today. That's just the fossil fuel. That leaves nuclear in. Is Saudi Arabia going to do that, or the Middle East, or Africa, or Southeast Asia? Even Europe and the U.S. Should they do it? Will their economies be robust enough to invest in the environment if they do that? What happens if we turn the lights down in the world 85%? I'm sorry. That doesn't look like the future to me as an energy person. It looks like the past. The future turns lights on across the world. It provides clothing and shelter and clean water and addresses hunger. Education with lights at night and in your home, and healthcare with vaccines and freezers and refrigerators. Women are going for the water. Women are cooking indoors with the wood. They're not in schools when their male counterparts often are. It differentially impacts women negatively, the rights and empowerment of women. Immigration and migration. Autocrats control a lot of these poor countries, autocracies. They say they want to lift them, but their actions don't agree with their words. So people are trying to leave because they have no hope. Population growth, a great challenge, is directly tied. Fertility rates are tightly tied to education, which is enabled by energy. Environmental investment, talked a lot about that. And climate adaptation and mitigation. Okay, you start to bring all these things together, and that does change the world. And I think that's what you all want to do. In my little way, I'm trying to do that too. And so, what is sustainability? Global sustainability must seek secure energy and healthy economies and environmental health. And it's mostly in that order. You can't skip one of those 3 E's. Several billion citizens still lack access to secure energy today. 3 major forms: electricity, lack of access to it, cost, and clean cooking. Emerging and developed economies, they're using coal for power generation today. You've seen the data. It's unprecedented quantities. The dispatchable options, the baseload options, are natural gas, nuclear, and hydro. Renewables are wonderful, but they are intermittent. And they require mining of their own. Intermittent means you have to back them up with something else, and that something else is redundant, a battery or a natural gas plant. That makes it more expensive to the consumer, not more affordable. Okay? You'll hear they're cheaper, but only at the plant gate, not to the consumer. Ask Germany, ask California, ask New York. The data are very clear on this. Focusing on fuels on behalf of climate change is what? And I can't think of the right word. I've highlighted misplaced. Is it misplaced? Is it naive? That's pretty judgmental and condescending. Is it unworkable? Well, that's maybe my opinion. Is it incomplete? I don't know. What is focusing on fuels instead of what? It's something. Instead, focus on reducing the emissions. We've got to focus on the challenge with the fuels, because these nations aren't going to leave those in the ground. We got to help get them cleaned up quickly. Okay? And along the way, we need to look at mining and landfill and other impacts of energy on land, water, and air. To show you this graphically, we have our 3 E's, and I'll close here. This radical middle, sometimes it feels like it's shrinking in the Western Europe and the United States. We seem to be pretty polarized on some of these. You know, a lot of the world, that radical middle is growing, excited about the future. Reduce impacts of all forms of energy on atmosphere, air, land, and water, and they're each different. End energy poverty, we can do that, and build a global economy. Clean up fossil fuels, they're going to be used. Coal to gas, great. And capture the emissions, absolutely. Efficiency, wonderful way to use less and still do as much. Nuclear, where it's possible. China's building 50 new reactors today. The Middle East just put a reactor in. India needs to look that way. Geothermal, where the resource exists. Hydrogen economies, fuel cells in cars, as well as batteries in combustion engines. And distributed renewables for a lot of people who don't have any energy or much today at all. You bring all that together, you bring the energy, the economy, that's sustainable. Okay? That's sustainable. And it requires nonpartisan energy education and critical thinking. We're all partisan, we're all biased. We've got to break out of that and challenge ourselves to think that way. So we're trying to do that at Switch Energy Alliance, inspire an energy educated future. If you haven't seen some of our films and short format stuff, check it out. It's all free. We're building stuff for teachers in high schools and universities, and museums, and all sorts of things. So thank you for your attention. I really appreciate being invited tonight, and happy to entertain questions, and I'll bet there are a few. Thanks.
All right. Well, thank you, Scott. I really enjoyed listening to that. So what we're going to do now is entertain questions from the audience. And so if you have a question, please just go ahead and enter it into the chat. And Beth and Alex are going to collect questions, and I will relay them as they come in. And I guess, just as we're starting, Scott, I have sort of, I guess, a meta question, which is, the thing I take away from your talk is that for many of these problems we don't have solutions so much as we have trade-offs. And I guess the question is how we should go about, we being either citizens or students or politicians, weighing those trade-offs.
Right. Now, look, I think that's a great way to put it, Alex. And there, options and trade-offs are real across the spectrum. You don't want to trade off things that really impact the environment negatively, climate for sure, and other big regional things as well, or even local. You don't want to kill economies because then you can't invest in the environment. And so you have to begin to think about these things as in a systems approach, in an integrated way. And different regions are going to address them differently. That's about as straightforward as I can say that is the resources you have, the government system you work in, your level of development, what kinds of educational you are. That will allow you to do a set of things like Western Europe and the US have done. We've eliminated coal or getting close and replacing, but others are still going through that. How can you accelerate it? You can't judge it. You can't say, don't do it. We did, but you can. Because it's so affordable and available and reliable to them. But what are the options? Can you get some natural gas imported? Is nuclear possible? Can you expand your renewable base and get some distribution going on in that way? So that kind of exchange is then one that is inclusive instead of judgmental about approaches. And we really have to be, I believe, in the developed nations, much less judgmental and more inclusive. Because when you see this film, I've had so many people say to me, I had no idea. I had no idea that the numbers were that large. And how would
I would certainly say that.
Yeah. No, that's a great point. And it is trade-offs. So, but systems work is really cool, and I'm sure you're doing a lot of. You model climate systems. Hell, that's one of the most complex systems on the planet, right? And human systems are a little harder because we're not logical. So game theory doesn't work very well with humans because we do stupid things. But they're kind of predictable, and we can adapt pretty quickly to those. And I just highly, if you get nothing else from me or my talk, I just highly encourage you to look at these different sides and say, no, okay, that's real. Those are the data. What can we do? What can we do with those data to maximize on a couple things at the same time? Minimize environmental impact, maximize economic benefit. Don't accuse people or judge them or put terms on them that nobody's going to react well to, no matter what side of the term you're on. A more inclusive approach to it.
All right, I'm going to go to the chat questions. The first question is from Ken, and it says, is carbon capture a realistic option?
Oh, yeah. Full disclosure, I've had a team at the Bureau of Economic Geology for 2 decades on the storage part of carbon capture and sequestration. We don't look at the capture. That's others, engineering challenge. So the capture is realistic. It's even scalable. It costs money. There's an energy penalty when you scrub the CO2 out of a stack from a coal plant or a natural gas plant or other kind of petrochemicals plant or a hydrogen plant, etc. There's an energy penalty, but it's doable at scale. And storing it is actually doable as well. That's what the science shows now. We can put it away in tens to hundreds of millions of tons to even billions. The economics, it's still expensive, but that varies by region. It depends on, are your sources close to your sinks? Is some of the infrastructure already there? Are there incentives for it? Like the U.S. has something called 45Q now. You may not know this, but under Donald Trump, the incentives to store carbon went way up. And people are actually looking at doing this. And everybody goes, under Trump? Oh yeah. And then the other people, it's odd bedfellows, because there's like Environmental Defense Fund is very supportive of CCS, and then Sierra Club, not so much. And so you get these different, well, we don't want any fossil fuels, so CCUS just enables it forever. It's bad. And others are saying, yeah, but they're going to be there. Let's capture them. Isn't it about the emissions? And shouldn't we do something with those? And if it costs more, that makes them compete harder with other things in the market. So maybe that's a good thing too. So I would say it's technically doable. It's still got economic challenges depending on where you are geographically and geopolitically and developmentally. Okay? And you're starting to see it happen in a few places in the world at scale. The best places to do it that our team has found is offshore, not onshore. They're big sinks offshore, owned by one owner, the government. You can monitor it very well. The sites to capture it are very close by, and on the shore where a lot of industry happens. And you can, if something bubbles off into the ocean, you can shut it in. You're carbonating the ocean really, really weakly, like a lot less than your Coca-Cola. Okay, so it's a pretty cool place as you start to think about that for where you do CCUS.
Okay, so the next question is from Ganesh, and it says, how do you plan on leveraging biology for carbon management?
Look, there's a lot of neat, I'm not a biologist, full disclosure, not even close. There's a lot of neat things going on now biologically though, in remediation, in creating waste to gas sources. So rather than just piling up big piles of garbage, can we use biology, microbes and other things to create methane, capture the methane, and then use that methane as an energy source, so waste to energy, which is a pretty cool thing. Biology is pretty powerful still for bioremediation. So there are many environmental impact sites where microbes and other things can remediate the damage. In fact, I'll say proudly, my dad, who we lost just this year, is a geologist, and he got a lot of awards way back for cooperative bioremediation around oil fields in the 80s. Okay, and so it's been around a while and it's still doable. Other forms, you know, biofuels, I'm going to be candid, not my favorite. You know, and I even am conflicted because we have a little popcorn and corn farm in Ohio. But using the food for a fuel, converting carbohydrate food to hydrocarbons, both carbon and hydrogen, just different forms, not a real efficient process. And so, yes, it's good farm policy perhaps to have ethanol in your tank, but it's not the greatest energy policy. It's not a very efficient way to go about it. It works in some places like Brazil for biofuels, where they have great rain and soils that aren't being used for other things, not many fertilizers needed. So they can create a lot of liquids from biomass, if you will. They're not using the food, they're using all the cellulosic part. So it's a little different, cellulosic versus food. Works in some places. But biologically, I guess I'm not a giant fan of that, and I also don't think that it really is a CO2 reduction strategy. Yes, the plants take up CO2, and then you burn them and it goes back, and it seems like a cycle, but there is so much that goes on in between to go from the plant to burnable that is emitting CO2 all along the way. It's really not a zero carbon strategy. Even though Europe claims it as a renewable zero carbon, it's over half of Europe's, by the way, check the data, over half of Europe's clean energy is biofuels, and they're burning them to make electricity. so, wow, you know, we won't use natural gas. We're going to use something with a lot more carbon in it that we have to make. And so, yeah, but it's renewable because we can grow those plants, and you got to be a little thoughtful when you start to really look at the full cycle analysis of these things. That's just my opinion on it. I hope that addressed some of that.
Okay. All right, so the next question I'm going to take will be from Kunsang Chodin. It says, I'm from Newbury, Northern Himalayas of Nepal. The micro hydropower plant built 20 years ago, serving around a population of 300, has stopped functioning in June 2020, and people have moved back to traditional biomass energy based on this, and it is highly reduced work efficiency, especially now that it is harvest season. What would be your suggestion to mitigate this challenge, and can you suggest any alternative means of energy?
Yeah. Look, this is unfortunately, did you say Nibru? I can't see the name.
Nubri, Nubri, I think.
Nibru, nice, really very common actually in the world where you see good intentions, in that case a hydro facility, but we're bring aid and put in solar pumps, or like we did in Gunchukwa in the film where we brought solar PV microarray, and then it breaks, and the local citizenry doesn't know how to fix it, so you go back to doing what you're doing. Nepal is suffering from some fairly deep deforestation right now. In fact, you're not even allowed to legally gather wood from the forest except once or twice a year. We talked about that in Switch On, where we feature that. So you buy it, and they're buying wood scraps from furniture makers and other kinds of things, and it actually costs more than options. So if the locals cannot fix or won't fix that hydro facility, my first reaction is fix the plant, a hydro plant. You know, it's a great little power plant, no emissions, the infrastructure's already there, there's obviously transmission lines, you don't have to build anything new. Get some investment and fix that. Given that that might not happen, some other things that we are seeing, for example, we've cooked with electricity. That's clean, but maybe you don't have the power because the hydro's out. So LPG, liquefied petroleum gas, no emissions in the house other than CO2, removes all the particulates and the sulfur and nitrogen and everything else. That's a pretty good strategy. Biogas, another nice one, when you generate it there locally, so you're putting human waste and animal waste, and most agrarian societies have livestock into the bioreactor on your own site, and it costs front-end money. The government in Nepal subsidizes about half, you pay half, but then you have natural gas that's free essentially forever, and the reacting system is very simple. So that's another decent option. Micro wind turbines are good too. You know, these small wind turbines that can be fit for purpose and fit for scale are very important if there's reasonably steady wind. And then here's one that'll probably rock everybody a little bit, but I'm actually a pretty big fan of small modular nuclear reactors. And this is the 50 megawatt or 100. A big nuclear reactor, by the way, is 1,000 megawatts or a gigawatt. So 50 megawatts is a 20th the size of that. They're not very big. They're next generation. The fuel cycle is extremely efficient, so small amount of waste. And again, you can deploy them locally and power with steady, always-on electricity a pretty good area with 50 megawatts. This is not trivial stuff for villages and clusters of villages. You don't even have to be on a grid necessarily. So NuScale, if you want to Google NuScale, they're one of the U.S. companies making small modular reactors, and they've passed some pretty interesting regulatory hurdles. If you're passionate about climate change, nuclear, that's part of that solution. It's scalable, no emissions, very affordable once it's built. China's building 50 new reactors today. The U.S. hasn't built any in a while. A couple under Obama, second term under earning the news on brownfields. But nuclear is a big piece of that. It could deploy that kind of steady, affordable, clean electricity. And then, again, the next generation, really inherently safe. Okay, so that's some options. I could probably think of more if I kept babbling, but the first thing I would try to do there is get that hydro facility fixed and then begin to get options to supplement it. Some renewable options and maybe some natural gas options on the cooking side.
Okay, so the next question is from Eric.
By the way, real quick, Alex, I just wanted to say one other thing. This Saturday, we're having the finals of the Switch Energy Case Competition, International Case Competition. And we didn't know what we would get. We had 260 teams from 37 countries, 140 universities register for this. Teams of undergraduate and graduate students from all 6 continents. The finals are this Saturday. They're going to stream them live on Facebook. I'll say something at the very end. We have 7 finalist teams. And their charge was to look at energy poverty. 3 nations, and they got to pick one of the nations. What would you do? And they had 2 weeks. So they went through this very exercise. What's available, resource-wise? What's scalable? What could the government do, given the government how much can they really afford? So they had to really start converging on lots of different energy, economy, and environment solutions. The ones that did really well tried to pull all that in. If you haven't had a team in there, next year we'll do it again. We were blown away by the scale. We had 200 volunteer judges and mentors. A volunteer mentor for every team that registered. So it's been a lot of fun.
Sounds like a great competition.
It's cool.
Okay, I'll go back to Eric's question. It says, could you speak to China's approach to natural gas? Do they not have the source rock particular to shale resources? By using coal, are they ensuring energy independence and attempting to be independent from shale-rich countries like the US, Canada, and Russia?
Yeah. Uh, pretty much yes to all those questions. They really don't have the shale resources, and at the Bureau, we've actually done studies there. We looked at freshwater shales, not marine shales. Those who aren't geoscientists, muds form in freshwater and oceans. And so we were looking at the freshwater to see, kind of some production. China has some shale, but mostly they're bringing in LNG, liquefied natural gas, and mostly from the Middle East. Okay, so there's kind of this handshake going on delivering that. A lot of coal in China, yes, for the reasons you said, a security challenge, affordable, available, reliable, dirty, for the most part, both mining and emissions. And then big hydro facilities, the largest power plant in the world is the Three Gorges Dam in China. It's about 24 gigawatts. That's like 25 nuclear reactors, one big dam. Now they moved 1 million people when they flooded it. Now can you imagine let's go to St. Louis. Hey, we're gonna just flood the Mississippi. We're gonna go ahead and move St. Louis over here. How would that go? So there's some advantages to communism, and that's one of them. You can do things that you just say it's going to happen. They have a lot of renewables, building solar and wind for sure, and looking at some geothermal, etc. So China's looking at all of it because the scale of demand growth is unprecedented. 4 times the number of people that are in the United States, and they're all coming up that scale. And it's not just in China. The 65 countries I've been in, China was present in almost every one of them, peacefully and openly, but acquiring minerals, building infrastructure, lending money, and becoming citizens, especially across Africa. So it's a fascinating, when I showed you those data on lithium and cobalt and polysilicate and nickel and other critical mined elements for renewable energy, that's China. So another security challenge, are you going to just shift for transportation from OPEC, oil for cars, to China, batteries for cars? Who controls your fuel source? And governments are thinking pretty hard about this right now, and you should be too. Security, is it clean? Is it available to us? And so think multidimensionally on these things. We can solve it, but I think China has, I've been there 1 million times. We have great partnerships there in the universities and the governments, but make no mistake, it's the largest economy in the world, and it's doing what it needs to continue to grow.
All right, I think we have time for one more question, so I'm going to apologize to those of you whose questions I did not get to. But so Scott, the last question is from Bennett, and it says, what do you think the next step is for America as the largest per capita polluter to address climate change through energy?
Yeah. Well, we're not quite the largest per capita polluter, but we're up there. We're certainly the largest of the big economies. I like what we're doing overall, mostly because of market forces, reducing the heavy carbon intensity in the power sector mix and replacing it with natural gas. We should do more nuclear and growing the renewables. So that's a good trend in the power sector. I like the idea of choices in transportation. So rather than just internal combustion engines, we need to add electric vehicles. They're great in cities, plug it in at night, drive 2 miles for an hour in traffic with no noise and get there and come home and charge it again. Not so good for other places. And I love fuel cells. I think we need to bring hydrogen back into the mix. It's a different form of electricity carrier. So choices are good. I think it's silly for California and New Jersey to outlaw internal combustion engines, gasoline and diesel. You know, it's probably going to look like 1960 Cuba when that happens. I'm actually not even kidding, because people are going to continue to drive combustion engines. They're just going to fly them somewhere else. And so, you know, every time policymakers try to pick energy winners, they fail miserably. And it's not because they're not good intentions. They just can't outsmart the markets. If markets don't adapt and adopt it, it's not going to happen. So I love the choices in our transportation side across, again, fuel cells, batteries, and combustion engines. I think we need to look very hard, and it needs to be led by you all, at what we want to improve on energy. So what are those environmental impacts that we need to improve on? And then set up incentives and systems to happen. And I don't care if coal can get all its CO2 out of the emission stream, or a lot of it. Great, burn coal. You know, scrub out your SOx, your NOx, your mercury, and your particulates. That's mostly already happened in modern coal plants. But, okay, isn't that what we were trying to do? Reduce the CO2 emissions. Make it more expensive. It might not compete. Okay, so other solutions win. But rather than trying to eliminate certain fuels and pick winners passionately, let's look at the outcomes we're trying to prevent. I think that you all are going to say someday soon, where are all these mines coming from? And you might say, we don't want them in my backyard. You mine over here and use children to do it, by the way, in North Africa and China. And we'll move our fuel supply security risk over there. And oh, where are we going to put our batteries when they wear out? Oops. And so I think you're going to be dealing with some of these realities of energy density, because the challenge with the biggest challenge with wind and solar and batteries is not that they're intermittent. That's a challenge. You got to back them up, but it's that the density is so low. You know, I didn't dive into that, but it's called power density, and on an area basis or a volume or a weight basis, liquids and gases have a lot more energy than the sun and the wind and batteries. And so you have to just have a lot more stuff to equal that. And uranium and thorium are so far beyond everything else, you can't imagine the power density. It's off the scale. Go look at the things on Switch. So that's why it takes so much stuff. It's not that there's a bunch of people scheming behind the scenes in corporate America trying to keep these things going. That's just what it is. That's the physics of it and the economics of it. So I think you're gonna be looking around going, where did all these mines come from, and why are we burying all this stuff all of a sudden if we don't balance these thoughts out? Okay, so that's my opinion. I'm a geologist. Take it for what it's worth. Look, I enjoyed being with you tonight, and if there are more questions, Kathleen and others, send them my way. I'll type some answers and share them.
All right. Well, thank you very much. I think other Alex is gonna take it back here.
Yes, sorry. I want to say thank you so much to Scott and to Alex for being with us tonight, and thank you to all of our participants. It's been a really great evening. And I just want to let everybody know that the climate change program does have 2 more speakers lined up for the spring. We'll have Clarita Left-Hand Begay and Drew Schindel. We're really looking forward to those events. Also, the Midwest Climate Summit's final event of the fall is on November 20th. You can check us out at climatechange.westall.edu, or you can follow us on Facebook or Instagram at WashU CCP. And I'm going to drop some links in the chat, including the link to Scott's film that he was talking about this evening. So thank you so much to everybody, and we'll see you guys next time.
Thank you.